In this video, we're going to build a 2D camera system and an optimized grid map for our .io game. And we're going to build it from scratch. So, to start things off, we'll first set up our environment and build our canvas, and then render our local player and implement the camera translations step by step. So to start things off, we're just going to go to our index.html and we're just going to do a quick shortcut. We'll type exclamation mark and then press enter just to get our setup ready. And we can just name it map tutorial. And next what we want to do is we want to actually open this with our live server so we can see our web page right here. And we're going to create our canvas so we can draw what we need to and manipulate whatever is necessary. So we'll do canvas ID. We'll give it an ID of, we'll call it game canvas. Game canvas. Just like that. And we're also going to create a script called main.js just to draw everything out and run our main game loop. So main.js. And we actually want to reference this script. So we'll do script source is equal to main.js, right? So now that it's referenced, we can create our canvas. So to create our canvas, we'll just declare a variable that canvas is equal to document.get element by ID. And remember what we named our canvas, it was game canvas, so we'll just reference that. And next, we're just going to create a context, the context for our canvas. And we'll call it get canvas.get context. And since it's a 2D.io game, we're just going to make it 2D, so 2D. Context will be 2D. Everything we draw will be 2D, right? And next, we want to create a way to essentially draw these grid lines, right? So to start things off, we will, okay, first of all, let's actually make sure we can see our canvas, right? So we will give the canvas a background, so we'll do style is equal to background color, right? Just do RGB 050. Let's see what that does. Okay, we save it. Okay, nice. So here's our canvas, right? It's a bit small, so what we can do here is we can actually, well, actually, if you've ever played .io games, you'll notice that they're most like the canvas or the background is fitting the screen. It's like the full thing, right? So what we can do here is we can create a function called resize. So function resize. And in this function, we'll do canvas dot width is equal to window dot inner width. So this will make it match the size of our width of the window's width. So it'll correspond to what its current size is. So we save that. Nothing happens yet because we didn't call it, obviously. But if we do something like, we just call resize, right? Nothing happens as well because we have to add an event listener. So we'll do add window.add event listener resize. Oh my god, what is my typing? Why is my mouse like that? Okay. But yeah, okay, we'll call it resize. Okay, actually I should rename this. I'll just call this resize canvas because it's built in, right? So we'll just do resize canvas. Okay. And we save that. Why is this so weird? Okay. It's not working because we changed the name, right? So resize canvas. And now if you save that. Okay, wait. Canvas.height equals window.inner height. That should theoretically work. I don't know. Why is this tripping? Oh, it's because of the brackets, right? Okay, that should work now, right? Okay, let's save it. Okay, yeah, there it goes. Okay, and you can also notice that there's like some white spots and some scrolling. So what we can do to fix that, if you're a pro at HTML or CSS, we can just add a style. So we'll just call it style. I like to give it some space. But what we can do is we can use an asterisk and then this curly brackets. This just means reference everything. And if you actually inspect this, scroll down, you can see that this is the general setup, right? So what we're looking at right now is we don't want these margins or these borders. So what we can do is we can set margin to 0. We'll actually set all of them to 0 just to make our life easier. We'll do border 0, and we'll also make the padding 0. And then if we save that, you'll see it fully optimizes the screen, but you can still scroll, which is not what we want. See, if you scroll left, right, up, down, you still get these white spaces, which is very annoying. So what we can do is we can do overflow to hidden, and this just essentially restricts our scrolling movement. So now you see you can't actually scroll it, which is good. And now, next what we want to do is we want to also actually, before we continue forth, we should also create another script. We'll call it mapconfigs.js, because this is where we're gonna essentially create our map. But in main.js, we'll actually draw the grid lines of the map, right? So we'll call it map.configs.js, mapconfigs.js, right? And actually, I'm debating what should we do next. Should we draw the character or should we do the grid lines first? Okay, you know what? It might be easier if we first just create the character. So to actually like draw our character, we'll just make a player object. So we'll call let player is equal to curly brackets, right? And we'll do X position. We'll give it an X position, a Y position. We'll also give it a speed, so we'll call it 2 because we want it to be able to move. Actually, that'll be for a future video, but we could give it a radius, that's a must, and a color. So I'll just call it radius. We'll just give it, I don't know, let's say 20, and a color. What color should we give it? I'll just give it hashtag, let's just do FFFF. That'll make it white, right? Yeah, that'll make it white. Alright. And to actually render this stuff, we need a draw function. So we'll call function draw. And in this function, we basically want to create our player, right? So what we can do is we can also have a draw function in our player object. So draw, right? And this is just we're just gonna render it in here. So we'll just do context. We'll give it a color, so fill style. This is what our paintbrush is gonna be. And we'll give it this dot color. And we can also give it an outline. So we'll do context dot line width. So we'll give it a size first. Say 2. And the color of it, context dot stroke style, is equal to, I like black. Let's do black. So black would be what? 0, 0, 0. Okay, nice. And now to actually draw our character. So instead of the usual where we do context.fillRect, we're actually gonna make it a circle. So we'll do context.begin path. So this is how you make a circle. So we'll start the path. We're beginning the drawing. You don't actually have to do this most of the time, but it's for good practice, right? And so next we're gonna call context.arc. And inside arc, it takes almost the same parameters as rectangle, except there's a few additional ones, which I'll show you. So we'll do the position, this dot x, the x position and the y position, the radius, and then here we're gonna put a parameter of 0, because what this basically represents is where like it ends basically. So in simple terms, sorry, I meant where it starts. But the next parameter is where it ends. So you're just drawing. So if you've learned trig, you basically starting from 0 degrees, and if you want to make a circle, well, you have to end it. You have to rotate it all the way up to 2 pi, right? So that would be we can just call math.pi, and then we'll times 2. Okay. And you can also add an additional parameter. I think the last one was a boolean or something. I think it was like counterclockwise or clockwise, which way you want to draw it. That doesn't really matter for our case. So next, to actually draw the circle, you want to call context.fill, right? This will fill it with the colors like a paintbrush. You're just drawing it, right? You're actually like scrubbing it on the wall or whatever. And to actually get the outline, we'll do context.stroke. Context.fill is to actually fill it with the colors, and stroke is just for the outline. Okay. Now to actually draw this, we're just going to call player.draw, right? So player.draw, and this should draw it. But if you notice, we didn't actually call the function yet, our original draw function. Sorry if this is confusing, but yeah. So if you save it, you can see right there, it's like a little cauliflower. We can change the position of it. So I could just do like canvas.width if you want to center it divided by 2, and canvas.height divided by 2. So as you can see, it's centered now. Very nice. But this isn't the main goal of our video. So the main goal of our video today is to create the map, right? So to start off creating the map, we're actually just going to declare some variables, or actually it might be more appropriate to declare them as constants. So we'll do constant map width, and we'll just say 1,000 for now. And we also want a constant map height. So this is just defining our map, right? So and we'll also make it 1,000. So our map right now is a square. It's 1,000 by 1,000 pixels, and what we also want is, because we're making a grid map like most .io games, we're actually going to call it a grid. We're also going to make a grid size. So this is going to be the size of each grid, the little squares, the cubicles, and we can give it something like 50. So now to actually draw it, we're just going to put it in a function so it can be easily called in our main game loop function. So call a function draw grid. And we're actually going to pass in 2 parameters for this. And this will be important in the future. I'll tell you why. But in brief terms, we're actually, for the camera system, we need to pass in a cam X and a cam Y, because this is really important for how our player moves and how our player interacts with the map. Because what you see through the camera is completely different with its actual world coordinates. So we're just passing that for now. It'll make sense in the future, but in our draw grid function, we're just gonna define our grid lines so how should they look, and we'll just do context.stroke style. So something kind of similar to what we did in the player. So context.stroke style, and we'll just give it a color. I don't know. I like gray, so I might actually just say. Actually, I'm just gonna start. I don't know gray's code, but I think we'll just do like this color. Yeah, that's fine. Close enough. I also do context.line width. So the size of our grid. So I might actually just give it a smaller number. So maybe 1, 0.5. We don't want it too thick, right? And now here comes some of the more mathematical stuff, concepts. I should say that, yeah. Okay, so we're gonna declare a variable, let's start x. And what this basically represents is, it's basically where we want to start drawing our grid lines. So grid lines, they might seem easy, like on paper you can draw them really easily, but on computer you want to, it requires a more mathematical approach. So start x is just going to be the closest grid line to the player within the camera that we can see. And the way we're going to do this is, I'm going to show you. We'll do cam x. So this is the position of the x position of our camera divided by our grid size. So what does this do? Cam x divided by our grid size basically splits it into even parts, and depending on the position of cam x, it can have a decimal value, right? And so what we want to do is we want to round to the lowest integer so that our camera can render the nearest grid line. If we round up, it'll show the grid lines. It'll just be messy. The next grid line will be way ahead. So what we can do here is we can wrap this in brackets, and we can do math.floor. And what this does is it just rounds to the nearest integer. So once we get the nearest integers, so for example, if the position of cam x was like, I don't know, say like 300 or 302, right? And you divide by grid size, which in this case is 50, you'll get a float, right? Or a decimal number. And we want to round that to the nearest integer. So that might just be like 2 or 3 or whatever. Actually, I don't know the math, but so actually it'll probably be 6 because we declared cam x as 300, right? So yeah, rounding that to about 6, I'd say approximately, we get a integer value. And next we want to do is we want to render it closest to the camera position. So what we can do is we can multiply by 50 in this case, or grid size in this case. And we can do the same for the start position of y. So when we want to start drawing from y. So we can do let start y is equal to math.floor cam y also divided by the grid size. Sorry if my explanation is not really good. It's actually a lot easier to show on paper or just visually, but I'm currently limited in my resources, so I'll just describe it. You can do the research on your own if it's feasible. But next we're gonna add the end position. So we're gonna draw from the start position to the end position. That's how we're gonna draw our lines, and we're gonna use move to and line to. Move to just is where we start it, and line to is where we end it. And we're going to use a for loop to just iterate through each of the grid spaces and just draw the lines correspondingly. So let end x is equal to, so for our end x, this is, again, we want to render the last line that is visible within our camera view, right? So to do this, what we can do is we can just take our start x that we created here, start x, and then we can add our canvas width, right? And this pretty much just gives us the farthest grid line that is visible within our camera view. However, just to be safe, because we don't want any gaps, sometimes what can happen is when we move the camera, some spaces, right? If you can move it just in the right spot, sometimes the grid lines there can be a gap, right? So what we can do just to be safe is we can add another grid size. This is optional, but just to be safe, right? So and we'll do the same for let end y is equal to start y plus canvas dot height. Oh my god, what is client height? Sorry, canvas dot height. And we'll again add that safety measure, grid size. Right. So next what we want to do is what can happen essentially is sometimes, actually we'll get into that later, but we'll just render it just to show you guys what it looks like. So we'll use a for loop. So for let, should I use I, or we'll use I. For let I is equal to start x. So this is where we begin drawing our first grid line that is visible within the camera view, and while it's less than or equal to our end x. And then instead of incrementing by 1, we want to increment by the grid size so that it has that appropriate spacing. So we'll do plus equal to grid size, which in this case is 50. So in this loop, we're just going to begin our path like normal, except this time we're not making a circle. This time, like I mentioned earlier, we're going to use context.moveTo. And moveTo basically, it declares where we want to start or begin drawing our lines. It doesn't actually draw it for us, but it begins where we want to. It declares where we want to draw it. So moveTo, we'll start from our I, because I is incrementing by 50 each time. So I will be the start position for each line drawn vertically. Actually, I'll just comment this. This is going to be our vertical grid lines. And then our end, or sorry, not our end. This is the parameters in move to and line 2 are just x and y's, right? So for our y position, we're going to start at y, right? Beginning of y. And then for move 2, for line 2, this is where we essentially declare the end point of our line. So move 2 is the start, line 2 is the end. And so line 2 would begin from our I, same x position, because this is vertical, right? X stays the same for all of these iterations. It's just y that changes. So do end y. See, light and easy, very intuitive. But it can be hard to, like, you know, when you're first starting out, just thinking of it like this, procedurally. And then finally, to actually finish this touch, we'll just do context.stroke, just to give it the actual color, the rendering. And now for the horizontal grid lines, we'll do the same thing, just slightly different. I'll use J because I like J. I'm very used to I and J. For that J, this time we're going to do the horizontal, so we'll let J begin our start Y. And remember, these all start at 0, 0. Or not 0, 0, but relatively 0, 0. And J is less than or equal to end Y. And J as well is going to increment by 15 because we want them all to be symmetric. And same process, begin path, right? And then context move to. So slightly different. Instead, we're going to start from our x, start x, and we're going to end at our y. Remember, parameters x, y. And context dot line 2. We're going to do our end x. And j is the same. Y position stays the same. And then we're going to end it with the stroke. There. Save that. We haven't rendered it yet, but I'm just going to save it. And if you ever played .io games, you should also notice they have these borders, right, to just stop players from touching the ends, right? So we'll also create a border. I'm going to create a function called border. And again, you can also make this in draw grid, but I just like to do this for clarity purposes. Draw borders. No parameters needed for this. It's just brick by brick. It's just straightforward. And we'll just, for the border, we were really just making a stroke of the canvas. That's pretty much all we're doing. So we'll do context.stroke style is equal to, and we'll just use the same color as I used here, just to keep it consistent. Again, you can change it to your own liking. I like to keep it consistent. And we'll also give it a line width, so this is how thick it is. Let's make it extra thick, 10. And context, so here's where it becomes interesting. Now we're going to pass in, we're going to use this, what's called stroke rect, and this is just going to give our borders its thick, juicy outline. So it takes in the same parameters as fill rect pretty much, so the x and y positions. Oh my god, on a board, we don't need that. And because we're not actually applying this to our canvas, we're actually going to apply it to our map. So our map is a lot bigger than what our canvas can see, what our camera can see, right? So we'll do map width, right? Map width and map height. There. Okay, so the reason why I like to make this code modular is because it's a lot easier to manage and just run in our main game loop, right? Okay, so now we're gonna go back to our main.js, main game loop, right? And we're just gonna essentially draw our map right now. So before we do anything, something you have to know about most canvas games, web games, whatever, is you need to actually to like actually make things operate, like move and animate smoothly. We need to use what's called window.request animation frame. So window.request animation frame, and we're just going to pass in draw. It's kind of like a recursive function. We're just calling this draw function, our main game loop function, over and over again. And what this does is it essentially allows us to make things move, right? This is really important for input and also our camera, right? It's just refreshing the frames every time. So every sequence, it's very sequential. It's just a sequential function, right? And what this essentially is this is operating as our, I would say, our core engine logic. Okay, that's a bit of glaze. I wouldn't really call this an engine, but it's basically our camera loop. So every frame, we're just gonna, actually, I'm just show you context.clearRect. So what this does is it clears our frame every time we go through our game loop. Because the reason we have to clear this is because if we don't clear it, this, when we're moving, it'll just leave a trail of white behind. It never deletes the old drawing. So we need to clear our context. So we'll do, it takes in the same parameters as fillRect, so it depends on how much you want to clear. So for our case, we're actually just going to clear the whole screen, starting from 0, 0 at the very top left corner of our canvas. So 0, 0, canvas.width, canvas.height, right? And next, we're going to actually, after we clear it, it's important that we actually, this is a good practice. For our case, we don't necessarily have to do it because generally speaking, we are going to keep a white background for our map, but it's good practice to actually fill it right after you clear the rectangle. So we'll do context.fill style first. We'll give it a color. So I'll just give it FFF, so I'll just make it white. Actually, now that I think about it, I should change the color. I'll just make it red, give it good contrast. And we'll fill this rectangle, fill rect, 0, 0, same parameters, 0, 0, canvas.width, canvas.height, right? Just like that. Easy peasy. And next, what we want to do is, okay, I'll first tell you what's going on. So first, we are defining our main loop function called draw, right? And so every frame, what we're doing is we're calling clearRect and fillRect to essentially clear out the previous frame and give our background a crisp white coating, right? So now just think of, the way you can think of this is, now just think of the camera as an offset. So to center the camera onto our player, we're just going to subtract half of the screen width and height from the player's current coordinate position, right? And we'll call, so now what we'll do is we'll call context.save to essentially isolate our canvas state, so context.save. And what goes well with context.save is context.translate. This is going to move our camera, so it's going to move it in the other direction. So we're going to input parameters negative cam x, negative cam y. And the reason we do this is because, well, think, for example, like you're driving in a car and you're just riding by a lot of trees and a lot of landscapes and all that stuff. The trees themselves are not necessarily moving. The car is moving. So what we're doing is we're trying to not necessarily replicate it, but we're just moving the world instead of the actual camera, if that makes sense. Anyways, enough yap. Next what we're going to do is we're going to do context.restore, right? So that we can safely save our previous scene, our previous sketch, whatever, and safely run this loop. So once that's finished, actually, I should not put this here. Player.draw, I'm going to command X. Player.draw should be before restore because that's just going to make it disappear. Right. Okay, now that should make sense. Okay, currently, don't worry. I know it looks scary. This is normal. This is to be expected. Oh my god, what am I doing? Okay. But anyways. Back to our map configs. I just realized something. There's something important I missed. And what I missed is... yes. Okay. Yeah, I thought I was missing something. I swear there's no way it was this easy. But About this start X, right? So for start X, there is a problem. I just realized. What we do have to do is we have to actually use math.max, and in these parameters, we're just gonna return the greatest value, because what can happen is sometimes if our players need an edge or the camera gets negative, right? If the camera gets negative, that doesn't make sense. You're not supposed to have that. You're supposed to just stop at the very edge. So what can happen is we can get edge cases where we just have like the camera outside of the map, which is not normal. So to fix that, we can do we can pass in 0 for the start X, because the smallest X value we can get is 0, 0, which is the corners. So 0, and then start X. So start X can be negative, but since 0 is greater than a negative value, it will take 0 as the final result. And we're just going to do the same for start Y, math.max. Actually, I'll do end X first. End X is just equal to, instead of math.max, we're going to use math.min, right? Inversely proportional. And we're going to do map height. No, sorry, map width. What am I doing? Height is for the Y. Map width, right? The end of the map, which is map width, and then end X, which can also be negative or an external factor number. But yeah, so for Y, it's the same thing, math.max, 0, start Y. Thank God we calculated that. This is why just storing that in variables is really good. And then end Y is equal to math. What the hell? Why is my, okay, math.min. And this time it's gonna be map height, right? Map height. And Y. Okay, there we go. And back to main. Sorry, that took a while. It was bugging me. But yeah, okay. So back to our main game loop. So about the camera. So this is where it was getting confusing, right? But now it's gonna make sense. So what we're gonna do here is we're gonna call let camx now. So this is what we're gonna pass in for our draw grid function, right? So let camx. So camx, where do we want to position it? Camx is going to be positioned at the player X position. You might be thinking it might be positioned where the character is, but since we want our character to be centered in the middle of the camera, kind of like agar.io, df.io, all those popular .io games, what we're going to do instead is we're going to subtract the canvas width, but not just the canvas width. We want the middle of the canvas width, right? So divided by 2. So what this does is it essentially offsets the camera such that the player will be centered, right? If that makes sense. Because okay, if you draw it out, I actually drew it out on paper here, but if you draw it out, what you're doing is you're basically taking the player position, and then you want to offset the you don't want the camera to be on the player, because that would just make the player in the top left corner. So what you do is you take the player, you take the player's X position, you subtract the canvas, and then you divide it by 2, so you get the appropriate amount, right? And so next what you want to do is for cam Y, you just do the same thing, just with the player's Y position minus canvas.height instead. And so now that we have these values, we can easily just pass them in. So for drawing the grid, remember we created our draw grid function and our draw borders. We're actually just gonna put it in the same position, same area where we draw our player, right? So we'll do draw grid. So draw grid, cam X, cam Y, right? And we'll also do draw border, draw borders. What did I name it? Draw borders, yeah, draw borders. And we're just gonna call it because it has no parameters. We don't have to pass anything in it. And now, here's the tricky part. So for translate is just moving the canvas around, right? So for translate, we're gonna pass in cam X and cam Y as well, cam Y. But instead, right, instead of just normally passing in cam X and cam Y, also I just realized something. The reason why it's not showing is because we didn't reference it in our HTML document. Source mapconfigs.js. Okay, save that. Ugh. Okay. Okay, yeah. Anyways, so for translate, what we're gonna do instead is we're actually gonna pass in negative values for the cam X and cam Y. I know it's weird, but the reason we do this is because if you use normal cam X and cam Y, what's gonna happen is if you move to the left, move to the right by incrementing by its speed, what will happen is the camera will go in the opposite direction because it's moving away with it. So what we do is we do negative cam X, negative cam Y to essentially match with the opposing force. So it'll be like that driving analogy. When you're driving through the car, you yourself the world, the trees itself, the trees outside themselves are not moving. It's rather you are moving. So it's the same thing here. Your reference point is at the car, right? And you're just moving it around. So what the translate does is it moves the world in the opposite direction, so it matches with your pace, with your setup. Okay, so I actually don't know why this is not working. Let me refresh. Okay, did I name it right? Okay, I named it. Yeah, I named it right. Okay. Oh wait. Oh shoot. Okay, I see the problem. Okay, the reason why we're not seeing anything, I think it's because of the order. Yeah, it should be the order, because we should actually set this up first so that main.js can get the variables. I should have imported, but this should work theoretically. And we save. Oh, there we go. Look at that. Okay, so right now I know it looks kind of weird. It's definitely not centered. So what we can do is, okay, the problem with this is look at our position. Look at our player position. We're doing canvas.width divided by 2 and canvas.height divided by 2. So it's currently centered on the canvas, right? This is our canvas. This whole thing is our canvas. But camera-wise and map-wise, it's not in the center. And so this is what I was talking about, like world coordinates earlier. So what we have to actually do is we have to actually use our map parameters, our map constants. So instead for our x position, we'll do map width divided by 2. Look at that, nice. So our x position of our player is centered, and we'll do the same thing for y, map height divided by 2. And there you go. There you go. Look at that. Now our player is currently centered. Currently you can't move. That's a really easy fix. You just have to add an input handler for it. So just read input. I'll probably do that for the next video if I have time. Oh shoot, this video is probably so long. Yeah, this video is really long. My bad, guys. But yeah, for the next video, I'll probably do input handler. It'll be a lot shorter. This was horrible. I should have planned this, but hey, there you go. You have our map for our basic .io game. This is the basic setup. Trust me, this is not as hard as I made it look. I'm just an idiot. But it's a lot simpler than that. Once you actually understand how everything works, it's really easy to set up.